The greatest change in the human understanding about our solar system was the change from believing that Earth is the center to the belief that the sun is the center. One of the first believers in the idea of the sun being the center was with Polish astronomer Nicholas Copernicus. Copernicus made observations about the sky and developed his own theoretical model of the solar system based on his beliefs, which were supported by his observations. His theory is now known as heliocentric theory. Copernicus's model opposed the common beliefs of the people in 1543 and was never accepted at the time. After Copernicus's death, the Catholic Church banned his papers which supported his heliocentric model to protect their beliefs. Later, in 1610, Italian astronomer and physicist Galileo Galilei ended up helping support Copernicus's theory after the development of telescopes. Galileo created his own telescope and observed that Jupiter had its own moons, showing that not all objects orbit the Earth in the solar system. He also found more conclusive evidence to support the idea of a heliocentric solar system. The Catholic Church believed that the ideas that Galileo was supporting violated their holy scripture. The church ended up trying to stop the spread of heliocentric theory caused by Galileo. It wasn't until later that the theory was incorporated into accepted science. Now, to talk about the two types of planets. First, the inner terrestrial planets. These planets consist of Mercury, Venus, Earth, and Mars. The reason these planets are grouped together is due to their compositions. All of these planets are mostly composed of rocks or metals. They are also all relatively dense planets. The outer gas planets include Jupiter, Saturn, Uranus, and Neptune. These planets are significantly farther from the Sun than the terrestrial planets and are mainly composed of hydrogen and helium. Along with these types of planets, there is also a type of celestial body that orbits the Sun called dwarf planets. The most well-known of all the dwarf planets is Pluto. Many dwarf planets in our solar system are located in the outer asteroid belt known as the Kuiper Belt. Dwarf planets are most often defined by their sizes, but are also officially defined by a number of details given by the International Astronomical Union. There is also a special unit of measurement that is used when dealing with the long distances of our solar system. This unit of measurement is called astronomical units. An astronomical unit is defined as being the average distance from the center of Earth to the center of the Sun. This distance is equal to about 150 million kilometers. In 1687, Sir Isaac Newton published his theory of universal gravitation, which stated that all masses have an attracting force to all other masses. The size of this force is based on the masses of the two objects and the distance between the two objects. There are many types of celestial bodies in the solar system. These include asteroids, comets, meteors, and meteorites. Asteroids are made up of metals and rocky material, and comets are made of ice, dust, and rocky materials. A meteor is formed when smaller rocks or particles enter the Earth's atmosphere and vaporize before hitting the surface. A meteorite is an asteroid when it passes through the Earth's atmosphere and lands on the surface. There are a couple of parts in the Sun which make up its anatomy. The apparent surface of the Sun is called the photosphere, which is just below the chromosphere, and finally the corona on top, which extends for millions of kilometers away from the Sun. There is also the center of the star called the core, which is most of the nuclear fusion at 15 million degrees Celsius. Just outside the core is the radiation zone, which transfers heat through light energy. Outside of that is the convection zone, which transfers heat through the motion of hot gas. Temperature is signified in stars by their color, which represents their energy. The colors of stars are on the visible spectrum, with a red-colored star being the coldest at about 2,000 degrees Celsius. A blue-colored star is hottest at about 20,000 degrees Celsius. In between is the rest of the spectrum and the color white, which shows up when there is a mixture of all the colors at an equal brightness at about 10,000 degrees Celsius. Luminosity is the total amount of light given off by a star in all directions. Brightness is based off both luminosity and distance. Therefore, since luminosity cannot be measured directly, it must be measured with distance and brightness. As the distance increases, the brightness drops by the square of the distance. This means that brightness decreases exponentially based on the distance. In each star, there is a certain relationship between the star's luminosity and surface temperature. There is a diagram called the Hertzsprung-Russell diagram, also known as the HR diagram, that helps categorize stars into groups. There are 4 groups for which stars can be classified, which are main sequence stars, supergiants, red giants, and white dwarfs. The HR diagram also helps determine if a star is stable based on where it is placed on the diagram. If placed in the diagonal line that goes through the middle, known as the main sequence, this shows that the star is in a stable part of its life cycle. An example of a star in the main sequence is our Sun. The other groups include varying degrees of unstable stars. A light year is a measurement of distance often used to find distances outside of the solar system. The definition of a light year is given as the distance that light travels within 1 year of time. This distance equals about 9.5 trillion kilometers. Average stars, like our sun, have life cycles that last about 10 billion years. Each star has a different lifespan based on their own mass. Lifespans can range from millions of years for big mass stars to trillions of years for low mass stars. This is because a star with a higher mass burns brighter and hotter, which in turn uses the star's fuel faster. The beginnings of a star comes from a huge cloud of gas and dust called a nebula. After some time, the denser regions of the nebula collapse due to gravitational forces. This process creates a protostar. The protostar's gravity then keeps pulling the surrounding gas into itself, and the protostar continues to collapse, which increases its temperature and pressure. The star is formed when the protostar's temperature and pressure increases enough to allow nuclear fusion to take place at its center. This nuclear fusion allows the star to generate its own energy by converting hydrogen atoms into helium atoms. The nuclear reaction, which takes place in the converting process, releases a massive amount of energy into the surrounding area, keeping the star from cooling down and in turn keeping it alive. All stars start out as stable, therefore being put in the main sequence. Once a star runs out of hydrogen atoms in the core to use for fusion, the star becomes unstable. If a star has enough mass, it will become a red giant and increase its temperature to be able to fuse heavier metals together, like helium. If a star doesn't have enough mass to reach a high enough temperature to fuse more elements, its gravity crushes its core together as tightly as possible and becomes a white dwarf. The star then slowly dies over time, releasing its outer white dwarf layers into the universe. This nebula that is released will one day create another star and start the cycle all over again. Galaxies are large systems of millions or billions of stars, which are held together by gravitational forces. Galaxies can come in many different shapes, such as the shape of our galaxy, the Milky Way, which is a spiral galaxy with a diameter of 100,000 light years and a thickness of 3,000 light years in some areas. Black holes are regions in space where there is such a high amount of gravity that no particles or light can escape the gravitational pull. A black hole is thought to form when a massive star collapses due to its insufficient pressure to withstand gravity. This forms a type of star called a collapsed star. The collapsed star, in turn, creates an implosion, which forms a black hole. Due to light not being able to escape from black holes, astronomers have to observe the surrounding areas of black holes to determine their locations. Astronomers examine faraway objects using a method called spectroscopy. Through this method, they are able to see the visible light that is given off by different elements to examine the elements in celestial objects. There is a way of telling if an object is moving away based on if the visible light is shifted to the red side of the spectrum. This is called redshift. It was later discovered using this method that galaxies are moving away from each other at a speed proportional to the distance between them. This led to the idea of the Big Bang Theory, since the expanding universe gave the thought that the universe was once much smaller than it is now, and originated from one single point to expand outwards from. This theory is believed to describe the start of the universe and its past, but only future knowledge will be able to tell us if what we believe now is correct.